if we look at this second piece of paper, and I don't know what happened to number 1. It starts on number 2, so just go with it, okay? We're going to look at some of the traits Mendel himself looked at when he was a monk, and he was living at the monastery looking at the pea plants. Down here at the bottom, on this chart right here, this is where it's going to tell you the letters you're going to use and what traits we're going to look at, okay? So we're going to look at pod shape. Smooth is big N, and that's dominant over constricted, which is little n. Pod color, green is big G, and yellow is little g. That's the recessive color. Flower position is axial is big A, terminal is little a. I think what that means, axial is like the flower is here, and terminal, the flower is actually on the end. So this one's big A dominant, and this one's little a recessive. And then the last one, plant height, big T tall is dominant over little t short. So those are actually traits that Mendel himself looked at when he studied his peas. Okay? So number 2, draw your Punnett square. Always draw your Punnett square. Always show your work. This is kind of like math where you're going to want to show your work. And we're going to put one parent across the top. And we're going to put the second parent down the side. And then we're going to fill in the Punnett square. Now this is really important because this allows you to see that this parent has 2 alleles for this trait of flower position, but they're going to only give 1 to each kid. So when it makes this baby, this parent gives a big A, and this parent gives a little a. When it makes this baby, this parent gives a little a, this parent gives a little a. So everything across the top comes down, and everything on the side comes across. And the rule of thumb is if you do have a capital and a lowercase in the same box, you should always write the capital letter first. That's really important because you're going to add up the boxes that look similar, and if you do that, then you're more likely to see that they are the same. Okay? So does everybody understand how to fill it in? So down, over, down, over. Okay? Practice. All right. So now what we're going to do is we're going to look at the genotypic and phenotypic ratios. Okay? So genotypic. A genotype is the genetic makeup of the organism. We're going to use letters to say if the gene's like dominant or recessive. So we're using A's. So we want to count up how many would have the same genotypes and put them into a ratio form. Okay? So how many would have this genotype? 2. So for the genotypic ratio, you would have 2 have big A, little a, and you would have 2 have little a, little a. We would call this heterozygous because the letters don't match and hetero means different. And we would call this homozygous recessive. Homozygous means the same, and they're the same for the recessive trait. Okay? So that's the genotypic ratio. Let's look at the phenotypic ratio. Phenophysical. It's the physical outward expression of a gene. Okay? So looking down on your chart, your letters mean flower position. Big A is dominant for axial position, and little a is recessive for terminal position. How many are predicted to have axial, and how many are predicted to have terminal in this cross? Good. So we have 2 are predicted to have axial flower position, and 2 are predicted to have terminal flower position. Now, 2 to 2 in a ratio is the same thing as 1 to 1. So if that bugs you and you want to reduce, you can. I typically just leave it, but if you were to say take this on the STAR test and have this question, the answer, you might work it and see 2 to 2, and you go through all the choices, and 2 to 2 is not a choice, but 1 to 1 is a choice. I want you to be aware that that does reduce. 2 to 2, 3 to 3, 4 to 4. If it's the same number to the same number, it's the same thing as 1 to 1. Does everybody understand that? So just in case you were to see that, I want you to know that that can reduce. Okay? Any questions on that problem? All right, let's do number 4. We're going to skip 3. Y'all can do 3 on your own. I think that's pretty easy because it's already set up for you. Let's move to number 4 because it's a word problem. So you're actually having to use your vocabulary to set up the problem correctly. Okay, so it says cross 2 plants that are heterozygous for green pods. Would you circle that word heterozygous? Okay, so hetero means what? Different. So heterozygous means they're going to have a capital and a lowercase together. Okay, so for green pods, go down to the chart at the bottom of the page. And for pod color, we're using big G for green, and we're using little g for the recessive yellow trait. So if both plants are heterozygous, then how are we going to set this up? Good. Big G, little g, that's one parent. And it tells you that both plants are that, so the other parent is also big G, little g. That is what you call the P1. Anything that you're going to write on the outside right here, these are the parents. We call that the P1 or parental generation. Okay? All right, so now let's make the F1, which is the first generation of offspring. Let's make the babies. All right, so we're going to bring this down, and we're going to bring this over. We're going to bring this down, and we're going to bring this over. Notice I'm going to keep the capital letter first when I have that combination. Bring this down, bring this over, bring this down, and bring this over. So that's how that should look. Okay, let's do the genotypic ratio. How many will have a homozygous dominant genotype? 1. So you write 1, big G, big G. How many will have a heterozygous genotype? 1, 2. So 2 will have big G, little g. How many will have homozygous recessive? 1. So 1, little g, little g. So we have 1, big G, to 2, big G, little g, to 1, little g, and that's our genotypic ratio. Make sure that you put the G's in there and that you don't just do the 1 to 2 to 1. Make sure that you're specific on which one is which. So write it out. Okay? Phenotypic ratio. Phenophysical. The physical outward expression of the trait. What does that letter make the plant look like? Okay? So if it has big G, what color is it?
Green.
If it has big G, little g, what color is it? Green. So you add these together. So how many are predicted to be green? 3. So 3 are predicted to have green pod color. And this last little one right there, 1 is predicted to have yellow flower color because it doesn't have the capital G. Okay? All right, let's flip over and let's look at 8. Eight, 9, and 10 are a little harder. They're kind of more of advanced questions. 8, 9, and 10 kind of tell you what you're going to see in the offspring, and you have to kind of work backwards to figure out what the parents were that made them that way. So it's a little bit harder, so don't get frustrated. Some of the kids have to work 2 or 3 punnets to find the right answer, and that's okay because they're not hard. So, you know, if you need scratch paper, or you can work it on here, and then you just cross out the ones you don't want to stay. Okay? All right, so number 8, when a tall plant is crossed with a short plant, some of the offspring are short. A tall plant is crossed with a short plant, and some of the offspring come out short. Okay? So, tall plant. Here's the deal. That's like that hairy guinea pig. You just don't know, right? But the short plant, you know. The short plant has to be that, or it wouldn't be short. Okay? So I say start with what you know. Build your punnet and take one of your parents that you just obviously know that it has to be little t to be a short plant, And let's start with that. Okay? So let's reason through this. If I used this parent and I put this parent here, do I get any short babies?
No.
I get 100% tall babies. And that's not what the word problem said. It said some of the offspring are short. Are y'all with me? So I know this cannot be the genotype of the tall parent. So I'm going to have to use the tall parent that carries that recessive allele if I want to see any small babies in my Punnett square. Okay? So the correct one would be that. And if you do that, you see about half of those do in fact come out to be short. And that's what the word problem said. Some of the offspring are short. Okay? So your parents, which is your P1, are this little guy here crossed with this taller one there. So that's what goes on that line that says P1 equals. That X doesn't mean, hey, it's free, cross it out. You're not going to do it. The X means cross. You're crossing this with that. If you see that X, that means crossed with. Okay? Now, what about the genotypes of the offspring?
2 big T little t to 2 little t little t.
Good. 2 big T little t to 2 little t are the genotypes of the babies. And what are the phenotypes?
2 tall, 2 short.
Good. 2 tall, 2 short. These two are tall because they have a big T. These two are short because they don't. 50-50. Okay? That's how you do 9 and 10. If you'll look at 9, I noticed on number 9, it looks like 14 have terminal flowers. That should say 1/4. The printer, it just didn't print the fraction very well, so make sure that you fix that. 3/4 have axial and 1/4 have terminal there on number 9. Okay.